magnetism. Now we need to come up with an explanation for why is one area weaker than the others, and we've got that on video number 6. We'll get to that. But what does this do to the evolutionist? You just took away the idea that there are reversals. So now you go back to your original problem. The Earth's magnetic field is getting weaker. So how old is the Earth? If he wants to believe it's billions of years old, now he's going against some clear scientific evidence. It can't be billions of years old. That's for sure. Okay, the Earth is slowing down. Now, scoffers really attack this, what I'm about to give you here, this proof of a young Earth. But in 1990, the newspaper article here in Pensacola said, we're going to have to give 1990 one last tick. On New Year's Eve, they added an extra second into the clock. This article says, regular clocks use days as a measure, which are growing longer by 1,000th of a second or more daily as Earth's rotation slows. The Earth is slowing down. This is Astronomy Magazine, 1992. They said Earth's rotation is slowing down. June will be 1 second longer than normal because we're going to have a leap second. There's actually, it's called the International Earth Rotation Service. One of those government jobs. Somebody needed, somebody's uncle needed a job, so they started a new program to keep track of this. But the Earth is slowing down. Since they started keeping track of this, I believe 1973 is the first leap second. They've been adding a second to the clock about every year or year and a half. This International Earth Rotation Service decides when to do it. They try to do it in January or June. Now, do they wait 12 months or 18 months? That varies. What would slow the Earth down? The Earth is spinning in a vacuum. There's nothing in space. Why would it slow down? There are at least 3 factors that slow it down. Who can tell me what any of them are?
Gravity from the sun.
Gravity from the sun, I don't... Well, because of the inverse square law, gravity from the sun is pulling a little bit stronger on the close side of the Earth than it is on the far side of the Earth. There's an 8,000-mile difference there. So there's a little more pull on the near side than there is on the far side. I don't know if it's even measurable if the gravity from the sun would slow it down. The 3 factors, maybe a good bonus question at least, maybe not, or if not a quiz question. But one is the Earth is spinning, but the inside is liquid. So there's going to be a little bit of internal friction by the liquids moving around inside. If you were spinning a basketball that was full of water, there'd be some friction inside with this liquid versus this hard surface. And the crust of the Earth is not the same thickness at all places. It's thicker under the continents and very thin under the oceans. So you have a liquid moving a little bit inside of a ball that is not smooth inside, because the crust of the Earth is not consistently uniform and smooth inside. The liquid down inside, when it comes out, we call it magma. Volcanoes put out the lava. That's magma, the liquid rock coming out. The place where it changes from solid to liquid, nobody's ever seen this. This is theoretical. But they did try to find it, actually. They were going to drill down and try to find where does it change from solid to liquid. Some scientist, I forget what country he's from, he had a strange name, Moho Ravisic was his name. So in honor of Moho Ravisic, they named this place where it changes from solid to liquid, they named that area the Moho Ravisic Discontinuity. For short, they call it the Moho, okay? M-O-H-O. They spent a lot of money trying to drill down to find the Moho. Where does it change? The way that they know it changes from solid to liquid is pretty surprising and pretty ingenious the way they do this. When an earthquake is happening in San Francisco, it shakes the ground. They can have a machine here in Pensacola that can sense the ground shaking that far away. I mean, if I stomp on the floor here, can you feel it where you are? Well, if I drop a 20,000-pound weight on the floor here, they'll feel it down the block, right? As the Earth shakes, you can feel it at different parts. Now, the movement travels different through solid than it does through liquid. So they noticed if you have an earthquake in San Francisco, in Tokyo, their machines move. A few seconds later, they move again. It's not a different earthquake. It's the same earthquake, but they traveled through the crust of the Earth one speed and through the liquid at a different speed. Yeah, they're called S and P waves, I believe. You can study that in earth science about the different. Plus, they can discover, as the earth shakes, if it's shaking in San Francisco, on the opposite side of the world, which would be someplace near Australia, I would guess, they'll notice they don't get the right kind of S and P waves. It's like there's a shadow, and that's how they've determined the center of the earth has different parts. It has the mantle and then the core. They said there's something solid in the core, and I don't know how much is proven, but it is pretty reasonable that there seems to be a shadow to the S and P waves, or whichever is which, as they go through the earth, indicating there's something even more solid inside called the core of the earth.
Could it mean that there's something solid, or that could it possibly be hollow?
Or hollow, yeah.
And it's spinning and it throws it.
Yeah, if it's hollow, brings up another interesting set of theories you could come up with on that. Who knows? But anyway, the earthquakes, with these, they can tell what the crust of the earth is like. So one of the factors that is slowing the earth down is the liquid center. The other factor is the liquid surface. If you ever been standing out in the ocean and a wave hits you, knock you down, right? Well, those waves are hitting the beach all the time, aren't they? As the tide comes up, the water is pushing against the land. That's going to eventually slow it down. If you were spinning a basketball that had water all over the surface, the friction of the water dragging on the surface would slow your ball down faster. So you have internal friction. You also have external friction. This is from the tides. It's actually, there's a name for it. It's called tidal braking. It's like putting the brakes on. The tides have a very minimal effect, but they do have an effect. The tides are slowing the earth. The third factor, surprisingly enough, because the earth is spinning under a hot sun, the sun heats up the air, causes it to expand. As it expands, it rises. As it rises, cold air goes in the bottom. So you get hot air rising, cold air falling, rushing in, and you get wind currents. The earth has obvious wind currents, okay? The spin of the earth, combined with the heating and cooling of the earth, causes what is called the Coriolis effect. Some guy named Coriolis made it up, I guess. But the wind blowing against the mountains has a very slight slowing effect. So the wind patterns tend to slow the earth a little bit. The tides slow it, and the internal friction. Those are at least three. There may be more factors, but those are three that I know of. The bottom line is the earth is slowing down, and it's measurable. These are the dates when they've added a leap second to the clock. From 1973 up to 1996 I have here, for when they added a leap second. Because the earth is slowing down. Now if you go backwards in time, obviously the earth used to be going faster. I wouldn't put a date on this one and say if you went back, 1.4 billion years, you couldn't live here. Because then as soon as you put some kind of date, some skeptic's going to figure it out and say, no, it's 1.7 billion, see, you're wrong. And he's going to miss the whole point. The point is it can't be billions of years old. So what I say in my young earth proofs now is, look, the earth is slowing down. This everybody agrees with. This means it used to be going faster. Obviously. We know of no factor that's going to add energy to the earth. If a meteor hits the earth that's spinning, there's a possibility it'll speed